Oh, wow. Yeah. Yeah, we'll wait and see how it goes, and then maybe. Hi, my name is Andrew Wilkins. This is how not to bankrupt your PX4 project with Ascent Engineering. Who and why are we giving this talk? Have I ever bankrupted a company before in my 27 years on this planet? No. But I am with Ascent Engineering. I do engineering work for consulting and other companies. So Ascent Engineering, really quick, we provide drone software engineering consulting services for our clients. We build software on onboard computers. We modify some PX4 modules. We have done like APIs and QGC changes and Mavlink and Mav SDK. We kind of just go where we're needed and do these engineering projects for companies. During our tenure, we're a small company, 5 people. During our tenure, we see what companies are doing in this space. What's working well, what's not, what people are wasting their time on, and what's working really well for people, and they're able to make really quick progress in really short amount of time. The whole talk subject about how not to bankrupt your PX4 project is basically saying how not to waste large swaths of time and money banging your head on stuff that you don't need to be banging your head on. So we split this up into 2 parts, engineers and managers. We're first going to talk about engineers, which is, I feel like, the majority of this conference. First off, parameter files. I have been in so many meetings where they talk about parameter files and how much time they're wasting. Successful PX4 projects catalog and version control their parameter files, especially when you're developing these drones or these UAVs. I've been in so many situations where people are watching this drone toilet bowl or do some kind of weird thing, and they're like, why did this work 2 weeks ago? And they load up the parameter file from an email that was sent off 2 weeks ago between 2 employees, and all of a sudden they go, why is this parameter different? And who changed this and who changed that? Because developers go in and they go, well, what happens if we change this? And then they'll go, well, we'll revert it back if it doesn't work. And then they crash the drone and they forget that they need to change it back, but they'll use the same FCU. And then it just gets this snowball effect of why aren't things working? So use Git. Use Git to version control your parameters or have some type of structure set up to where you're saving the parameters. You have a main parameter set. People don't realize that they can do a subset of parameters in a .params file. If you have a sensor, you can have a parameters file that just has those parameters for that sensor and then overlay it onto your main parameter file. Comments, put comments in your parameters files, please, how the drone was flying, what sensors did you integrate, what still needs left to do. It's very easy, as you can see over here to the right, and I have my name, I PID tuned for the X4, some instability I noted in windy conditions, we'll figure that out later. Log files. I feel like we've all been in this scenario where we're watching the drone do something weird and everybody has their theories about why it's not working. And then there's that one dude who's like, well, what does a log file say? And then you pull it down and I swear it says it like right there in clear daylight. Stop wasting your time by guessing what the drone is doing up in the air. Grab that log file and pull it down. If you're having GPS interference, you can see clear as day in the graphs if you're having GPS interference. So stop guessing or saying, oh, it might be the GPS. High level, you use flight review. I mean, the Skynode does this amazing because it just uploads over LTE right to the cloud, and you can just pull it down. You don't have to connect a cable or anything like that. Pay attention to the y-axis in flight review. I've had so many times where people are like, yeah, see this line? It's like doing this. It's like, yeah, but it's from like 0.1 to 0.2. Like, it doesn't matter. Like, I don't think that's it. Lower level, if you want to go lower level, then pop open plot juggler, obviously. Turn on debugging for logging. There's the parameter, SD log profile. Like, do this from the get-go if you're going to be debugging on this stuff, because the last thing that you want to have happen is a fatal crash, and then you go, all right, well, what happened? And you're like, oh, I forgot to turn on this parameter for more debugging info. It's the same thing with SD log mode. Turn on from boot until shutdown, because errors still happen when you're trying to arm the drone or even after a disarm, like emergency failsafe. So Make sure that you have from boot until shutdown. At least when you're developing, when you're going to release, change that back to, so you're not filling up the space. But even still, I mean, the log replacement on PX4 is, you're not going to like fill up memory and cause it to shut down midair. But just my opinion. Don't forget to scroll all the way down in flight review. Like, so much gold that we found is in the logged messages and the console output at the very end of flight review. So don't just pay attention to the charts. There's explicit stuff in there. Simulation. Successful PX4 projects spend time getting their simulations properly set up. Time in the field is costly, right? You pack up the van, the tent, the cooler, everybody, you drive 30 minutes or whatever. It's costly. And then you run something, and then you have to go in, the sun is beating down on you, everybody's sweating. Oh, what'd I do? There we go. There needs to be a faster feedback loop, which is, here's what we're seeing, here's the change that we need to make, implement it, test again, here's what we're seeing. That feedback loop is important for simulation, and I feel like this is kind of an obvious thing, but it doesn't happen all the time with companies. They don't spend enough time in the simulation. Gazebo is not that difficult to learn. If you want to get like a sensor set up, or like even make small changes to your like a configuration, it's not that hard if you know C++. So I guess a caveat. You can turn on wind, outside forces. You can apply newtons in certain directions, and what happens if we throw the drone? We've done that before. IR lock already in there. Distance sensors already in there. It comes with a lot. PX4 comes with a lot in Gazebo. Various models, various worlds. It's easy to add and customize is essentially what I'm saying. And you can modify the code in simulation to run with something that you have run on the mission computer. You can have those talk. Don't need a one-to-one copy of your drone. Most of the time, it's just not worth setting up this whole SDF file of your airframe. There's the IF750, there's the Iris. Those are two of the most commonly used, I feel like, for simulations. You don't need a perfect one-to-one comparison of your drone in real life, at least for initial testing. And also, I hate JMavSim. I'm just going to say it right now. I hate it so much. Just install Ubuntu on your machine and use Gazebo. I know that it doesn't require as much computing and stuff like that, JMavSim, and you can run it on Windows and Mac. We're going to get to that later, but I don't like JMavSim. Don't use JMavSim. Desktop setup. Successful PX4 projects run Ubuntu and Visual Studio Code on desktop. I don't know, some of these companies, we're married to Windows, but we can't run virtual machines. It's all right. But your development time is going to take a little bit longer. Ubuntu, we're all engineers here. We know what it's like to set up these environments on our machines. Whether you're using VM or bare metal, you want Ubuntu on there. I think it's 20.04. It works like a charm. There's setup scripts, and it handles dependencies well. There's great tooling. Even QGC, I feel like, runs better on Ubuntu. I've been out in the field, and people with Windows machines are like, yeah, why can't I communicate with the drone? And I take their telemetry radio and plug it into my computer, and all of a sudden it's working. Visual Studio Code, just a great tool. We all know there's a PX4 debugging tool online about how you can debug very easily and set up debugging in Visual Studio Code. And also, there's an SSH plugin. So you have your onboard computer that's on the drone. If it has LTE connection and you're out in the field or you want to program on it, you just download this plugin, you type in the IP address. It's as easy as SSHing, and all of a sudden you have all of your source code right there. You're not in terminal opening up Vim and trying to learn that. Although I do appreciate Vim over Nano. Steel. Successful PX4 projects analyze how other open source projects interface with the UAV and take from them. So projects such as QGround Control, MAV SDK, PX4 avoidance, you should leverage these as much as possible. And if you have an issue with them, then what you should be doing is you should be implementing that new feature or bug fix or whatever and pushing that back up to the cloud. But when you see something happen in QGround Control, you can open up the source code and see how are they doing this, such as like do reposition command. How is that being sent over? How are we uploading rally points? You can pop open, so many times I've popped open the source code to queue ground control and watch what they're doing in there and see what's going on and say, okay, like we can do this on whatever on the web interface that we're using, on the onboard computer that's passing around raw Mavlink messages. You can look at other projects and then implement that on your system. Use ripgrep. I love ripgrep because you can easily look up certain terms that you think, oh, I think that the code might live somewhere in here, and use ripgrep and you can find the file. It's awesome. Be lazy. We're engineers, you know. We just need to get to the objective as quickly as possible and make sure that it's, well, not as quickly as possible, make sure that it's done right. And if we take from some of these other open source code bases, then we can make sure that it's done right. Integrate with ROS2 and Mav SDK. Another one. You'd think that that'd be kind of obvious, but it's not always true all the time. Successful PX4 projects utilize ROS2 and Mav SDK. ROS2 is the right way to do these systems. Compartmentalized. Like the easiest way that I've explained this to a business person is like, let's say you have your communication node, let's say you have your drone node. If your communication node goes down, that shouldn't affect your drone node, right? You don't want to have your drone be doing weird things in the air because there's nothing communicating toward it. Make it compartmentalized with ROS2, easy messaging. Pre-made node for sensors. If you're gonna buy like a sensor or something to integrate with a robot, a lot of the times these companies will come out with a ROS node that you can just download and you don't have to do anything. You don't have to figure out, oh, how are we gonna interface with over what baud rate, UART or I2C, yada, yada, yada. They already have these pre-made nodes in ROS that you can utilize. It's fantastic. UORBs with micro RTPS. That's, you know, you don't have to listen to Mavlink messages anymore, and you can get like very high bandwidth UORB messages about what's going on with your UAV. Mav SDK, if you're not going to use ROS2, Mav SDK, beautiful. Higher level control, especially if you want to like upload missions and stuff like that. It's supported in C++, Python, Swift, Java, Go. There's some other beta versions out there, but I mean, why would you need them? That's really the right languages to be using. Raw Mavlink, I try not to use it. Obviously, in certain scenarios, you have to. James over here uses Raw Mavlink, and he loves it. That's just my opinion, especially projects that are trying to get off the ground, that are trying to make progress quickly for a demo. Utilize these components, utilize these libraries. Setting yourself up for failure. As you can see here, we have a gentleman who's thinking about going down the path less traveled. Wrong. You should definitely go down the path more traveled if you're trying to create a project in this space. Don't deviate heavily from mainline. If you think that, oh, we're going to take what's on PX4 mainline right now, we're going to branch off, and we're going to do this whole other cool thing, and it's going to be awesome, and everybody's going to love us, you're setting yourself up for failure if you don't plan on pushing those features and changes back into mainline. Because in 6 months, there's going to be a whole more load of features and bug fixes and everything that you're going to completely miss out on. And if you think that you can just kind of overlay those onto your branch, good luck. Doing everything on the flight controller. We've had people come to us and they're like, well, you know, we want to do this and we just kind of want to keep it on the flight controller. And it's some complex, computational heavy thing that's like obstacle avoidance, but we're just going to do it on the flight controller. Bad idea. Processing power. There's not like a whole lot of processing power on just a normal FCU that you can utilize, and you don't want to be interrupting those critical pieces of code that are keeping the drone in the sky. And especially now too, it's not that hard to put a computer with your FCU. Modal AI over here, not to call them out, but the Voxel 2 is essentially like the FCU and the mission computer in one, 16 grams. But I mean, you can do this with a Raspberry Pi and a Holybro 4, PX4, 4, you know, and development time. It's kind of a pain if you're going to be making changes to make changes to the PX4 Autopilot, compile it, plug in, reflash, make sure that everything's all set up, and then go again. It's a lot easier if you just have it on an onboard computer. You make your changes, you compile, and then you just hit go. Nothing changes on the FCU that you really have to worry about. Burning time figuring out what someone else already knows. Write an email. This is a huge time sink, time and money sink for a lot of businesses that we've seen. Engineers, if they have a problem, they like to hammer on that problem until it's done, right? Let's take integrating a Gremsy gimbal, for instance. Sometimes it doesn't interface right, or maybe like the roll axis, and you're, why is it doing this? Why is it doing that? And we've seen engineers in these types of scenarios spend weeks trying to figure something out. They can honestly be solved in an email. Like, hit up these companies, Hollybro, Emerald Robotics, Gremsy, uBlocks, Modal AI has great support for them. Hit these companies up. They'll respond. They want to solve these issues just as much as you do. And you're going to waste so much time on an issue that has already been solved by somebody else, or that you could get help from. This is definitely a call out to engineers. Think about your managers and the money that the company is wasting on you just sitting there, just spinning your tires. Putting off documentation. Classic. Documentation needs to be there if you're going to make changes. If your team is expanding, if you plan on leaving your company, you don't want to be leaving them with nothing. You want that documentation to be there so that when that new person comes on your team, you can say, okay, look at the documentation here, like even how to build and deploy. It's amazing how many places don't have documentations about how just to build, deploy, set up, troubleshoot. Simple documentation is needed, so don't put it off. Doing something that feels unsafe. If your manager or your boss asks you to do something that feels unsafe, especially in this world, no, I'm not doing that. I'm the one that's in control of this. This feels unsafe. We're not doing it. These things can hurt people. I know it's not popular to say. Probably not a lot of investors are tuning in right now, but these are dangerous things that can really hurt people. I have the scars to prove it. That happened a while ago, not currently. A lot safer now. Okay, managers. So we're done with engineers. We're going to turn this a little bit over to the managers. Development drones. Successful PX4 projects buy cheap drones to crash with. This is the Hollybro X500, I believe, V2. I'm not saying that this is a cheap drone, but comparatively to a lot of other drones, it's cheap. And you can crash these things. And you just order more from Hollybro. They have pretty good delivery times, especially just with the airframe. Production drones are expensive, whether you own it or not. You see drones out in the marketplace that are between like 5 and 15 grand, and even higher than that, especially if you have some fancy sensors on there. Lead times, we all know what lead times are, especially today's day and age. So it hurts when you crash a drone. Buy cheaper drones to test software, sensors, and configurations. So if you crash, it's not a whole, oh my goodness, we got to get mechanical now involved, and we got to source these, and these parts are different now, so we got to make a square peg fit in a round hole. Buy the cheaper drone, you can crash it. Buy 5 of the kits so that you have extra parts sitting around. This will lower the downtime for development. Also, we love 3D printed drones, like 2 hours on the 3D printer, and you have at least your airframe back up and running again. And like I said before, Hollybro X5 series, like around $250 right now online. Test checklists and enforce documentation. Again, with documentation. Successful PX4 projects create checklists for end-to-end tests, meticulous documentation. Test checklists. Do not let engineers make these test checklists. And when I say test checklists, I mean, let's say you create a release, you push to master, and you're like, all right, we're going to go. We're going to fly this thing. It's in master. You should have a long test checklist of stuff that's just, number one, simple. Make a mission. Up, over, down. Next checklist. Make a mission and update it halfway through. Even stuff that you've proven out before, you need to be testing those again, because a code change can really mess you up on the simple stuff. And you want to make sure that you're not pushing something to production that can mess up the simplest things, especially in front of customers and investors and whoever. It looks really bad to mess up on the simple stuff. So add these to your test checklist. Do not let engineers make these. Managers know what the customers want. So you need to make these test checklists for the customer and the clients. And also subconsciously, I'm a software developer and I've been here before. I make test checklists that I know that subconsciously my code's gonna pass. Just because it's oh yeah, I of course I accounted for that. It's in the test. But you really should be making those test checklists as a manager. And then run each time before you make a release to prevent regression. Like I already mentioned, documentation, same thing as before. I usually tell people just assume that your engineers have a shelf life of 2 years, especially how software engineers are nowadays. They can leave. And so many times we've come to a company who's called us and said, our lead engineer left, lead software engineer left, can you come over and help out? And we get there and there's just like no documentation, not how to build it, not how to deploy it, not, oh, here's the gotchas, here's the stuff that we need to work on, no issues in the GitHub repo. So you need to make sure that you're keeping up with that. Suggestions, Git readme.md, super nice because they just live right there in the repo. And then Gitbook, super nice. You can link it with GitHub repos, everything looks super great. And then you can get links to pass that off to maybe one of your customers, a new guy on the team. Mistreating engineers. Successful PX4 projects let engineers be engineers. See this time and time again in this industry. This kind of meme represents kind of how it feels to a lot of people in this industry right now. You have C-suite investors, clients that are hammering down, when is this demo going to be? When is this feature going to be implemented? The best managers shield their engineers from this, and they don't pass it down onto them. They say, hey, we got a demo here, we're kind of gunning for this, but they don't take all that pressure that they're getting and pass it down to the engineers. That's going to create burnout. That's going to create these stressful scenarios, and engineers don't think well under stressful scenarios. They think, how can we make this work immediately? And that introduces fitting square pegs in round holes. I was talking to James last night, and he was like, when you hit the demo, it's like, yeah, this works 20% of the time, but managers seem to think it works all the time. Oh, we have it. So let's move on to the next thing. Let's move on to this feature and that feature. It's like, wait a minute, we still need to get this right. UAV industry is stressful. And like I said, stressed engineers don't produce great products. Do not pass off business stress to engineers. That's your job, to take hold of that, process it, and relay it down to your team in a non-stressful manner. Changing goalposts, this happens all the time, especially in this industry. It's changing so rapidly, and investors and clients and customers want this and that and that and this. But changing goalposts, you're gonna end up with a hodgepodge of a product. And it almost feels like digging and refilling a ditch. First half of the day, we're digging the ditch, and then your manager says, oh, we're going over in this other direction. It sometimes feels like you're just refilling the ditch with the dirt that you just dug out. What's the point of this? It's demoralizing. And it causes people to quit. And then you have the situation where your lead engineer just quit. There's no documentation because you were on them about coming out for a demo, and now you're in a really bad spot. Overwhelmed with meetings. I feel like all engineers can get on board with this. Meetings interrupt flow. When you're in that coding state, when you're in that working state, and you have an hour-and-a-half meeting in the middle of the day, that just interrupts your whole entire day of getting stuff done. You have to let engineers go with that flow of, oh, I'm coding, I'm in it. Setting up demo dates and deadlines without engineers. Yeah, this is a great one. If you're with an investor or customer, please do not set up a demo date without checking in with your engineers, because you're not signing yourself up for more work, you're signing them up for more work. And you don't know the actual feasibility of that. If you're in a meeting, hey, let me check in with my engineering team on this and see when we can get it out. I think that might be doable, but we just need to go over the caveats of this. It's amazing how many times people just say, of course we can do it, and then it goes up in smoke. It's gonna bite you down the line. Give them the dues or you'll be screwed. Good, like too long, didn't read. So that's it. So thank you for coming to my talk, and a big thank you to my team at Ascent Engineering, Zachary Lowell, Austin Braun, Aaron Porter, and John Nomikos. They were the ones that kind of helped me put this project or this presentation together and kind of go over everything that we're seeing right now in the industry and with people that we've worked with in the past. So a big shout out to them. And if anybody has any questions, I'd love to field them. Sweet, 4:45 on a Friday. Yes, we are all feeling it. Thank you very much.